iterations. Just a quick check if you can see my screen still. Yes, okay. Okay, so the next topic is iteration. Now, what is iterations? In your syllabus, you've done a number of different types of equations. You know how to solve different types of equations. For example, quadratic equation, cubic equation, trigonometric equation, when you have sine, cos, tan, cosecant, secant, cot involved, logarithmic equations, e power something, right? Exponential equations. But there's still a lot of equations that you do not know how to solve. For example, if you had something like this, ln of 2x plus 1, that equals 5x cubed plus 2x minus 3. Now, do you have an idea of how to solve this? No, because we've got a cubic function combined with a log function, right? We don't have an algebraic method that we know of to be able to solve equations like this. Similarly, we can't solve this. So for problems like these, for equations like these that we do not know how to solve, we need some other methods, right? One idea could be finding the solutions using graphs, for instance. You could say, this is one function, this is another function. For this particular case, you could say, let's draw the graph of y equals tan of 2x. Let's draw the graph of y equals e power 5x minus 2. And using the graphs, look at the point of intersection of these two functions. Wherever they intersect, that's the solution of this equation, right? But that will not be very accurate. You can at least estimate the solution using this process. But how do you find more exact answers? That's what we use this process iteration for. It's called numerical method. It's a numerical method. There are actually multiple numerical methods that are there. In our syllabus, we only have iteration, right? This is one method that we use for solving equations. Now, what do we need to know about this topic? First of all, if you have an equation like this, for instance, x cubed minus x plus 3 equal to 0, if you wanted to solve this, you could say, you could make a graph of this like this, and then wherever it's intersecting with the x-axis, y-axis, because one function is this, the other function is this, y equals 0 is x-axis. So we are basically looking at where does this graph intersect the x-axis, right? Now, on the graph, we can see it's intersecting somewhere between -2 and -1. So using this, we have an estimate of the solution that, okay, this is going to be somewhere between -1 and -2. At least this much we can understand from the graph. Now, notice one thing. When this graph intersects the x-axis, towards one side of that, you have a positive y value, right? Y value is positive here. On the other side, the y value is negative. Between them, the y value becomes equal to 0. So when we want to find the solution when y is equal to 0, on one side of that point of intersection, on one side of that solution, the y value will be positive. On the other side, the y value will be negative. So that is one thing that you'll have to do, first of all, in this topic. You'll have to figure out by calculation whether a solution exists between two given values or not. Now, this is one way to do it graphically. So if you draw a graph, your graph will be intersecting the x-axis somewhere between -2 and -1. But we could do the same thing by calculation as well. How would that work? Let's say you've got a problem like this. Prove by calculation that a solution to this equation lies between -2 and -1. It says prove by calculation, not by sketching graph. How can you do that? We can say this is the function x cubed minus x plus 3 equal to 0. Now, whatever the shape of the graph is, it doesn't matter. There will be some point at which it intersects the x-axis, right? What we'll do is, we would say, let's input the x value -2 in this expression. That gives you -3. So that means when x is equal to -2, the y value is negative. Input x equals -1 in that expression, and that gives you a positive value. That means when x is -1, the y value is positive. So if at one point the y value is negative, at the other y value is positive, it's necessary that between those 2 points, the graph is going to cross the x-axis, right? And it has to it has to go from the negative side to the positive side. That means 0 will come in between that, right? when you go from negative to positive or from positive to negative, you have 0 in the middle. So that means if one value is negative, the other is positive, there has to be a solution between these two values. And that's what we say, since f of minus 2, if you call this function, if you call this expression f of x, f of minus 2 and f of minus 1, they have different signs. That is why there's a solution that exists between these two values, right? That's one thing that you have to do in this topic. They'll ask you to prove that a solution of an equation exists between two given values. What you would do would be, you would input those values in that expression one by one. You input minus 2, input minus 1. One of them will be positive, the other will be negative. And you would say, since the sign is changing or the signs are different, that is why a solution exists between those two values, right? Writing down the statement is important, where you either refer to the signs being different or that the signs are changing. That is why there's a solution. Let's take a look at another example. So let's say we've got this. Now, this is a different equation. We have to prove that a solution of this equation lies between x equals 1 and x equals 2. Now, we cannot just input values of x in this directly. First of all, we have to bring all terms to one side so that the equation becomes in this form. F of x equal to 0. You have all terms on one side, only 0 on the other side. So the first thing you have to do is you have to convert your equation to this form. Everything on one side, only 0 on the other side. Once you have done that, the expression that you have on the left side, you will call that f of x. And now you just input those values of x in this. Put x equals 1 in this, put x equals 2 in this. One of them is giving you a negative 3, the other is giving you positive 23. Sign is changing. You say a solution exists between these two values because of that. Okay. So that's the method that we use for this. First of all, convert the equation to this format. Bring all terms to one side. Find f of a, f of b. A and b are the different values that they give. If they have different signs, you say that a root exists or solution exists between those two values. But then we have proved that a solution exists between those two values. Now, how do we actually find that solution, right? For that, we have this process that we call iteration. Okay, we have this process that we call iteration. Now, first of all, let's understand how to use an iterative formula. We'll understand where this comes from later on, but how to use this formula? Let's say you've got this equation, x power 5 minus 5x plus 7 equal to 0. That's an equation that we've got. It's the same equation that we were talking about here. We have already proved that the solution of this equation is going to be between 1 and 2, right? The solution is between these two values. Now, what is that value? What exactly that value is, we have to find that out, okay? Now, for this, let's say we know this iterative formula that they've given. We will use this iterative formula to find the solution. Now, how does this formula work? You need a starting point for this, first of all. The starting point is going to be your best guess about the solution, right? Your best guess about the solution. So in this case, we have proved that the solution exists between x equals 1 and x equals 2. What's our best guess about the solution? We could say midpoint, right? It will be somewhere close to 1.5. You could some other value as well, but the convention is when we know that it's between 1 and 2, now we don't know where exactly it's going to be. We say, okay, our best guess is the midpoint. Okay, that's 1.5. So that's what we start from. So the first value that we use here, x1, that is 1.5. That's the first value that we use here. Okay. Now that's x1. How do you find the next iterations from this? When n is equal to 1, we get x2. We can get x2 from that. Put n equal to 1 here. You get x2 from that. On the left side, on the right side becomes x1. So the idea is whatever value you're getting in the previous step, you're inputting that in the next step in this formula. So 1.5, you input that as the value for x1 here. And then whatever result you get from that, this value, you input that again in x for finding x3. So the formula in the next step becomes x3 equal to 5x2 minus 1 whole power 1 over 5. You input that value here in place of x2, and you get the next value, and so on. You keep repeating this until the value becomes stable. Now, you will not be doing this manually. You'll be doing this directly on your calculator. Let me show you how that's done. This is just for understanding how this process works. It's an iterative process. You find one value, input that again in the formula, find another value, input that again in the formula. You keep repeating this process until the value becomes stable, and that will be the solution of this equation. Now, how do you actually do it? Let's say this is the iterative formula that you have. You know the starting value is 1.5. Okay. What you would do would be, in your calculator, you would input 1.5 first of all. That's your starting value. So input 1.5, press the equal to button. That saves this number in the answer button of your calculator. Now what you do is, you input this formula in your calculator, like this. You'll say 5, or bracket first, 5 into, in place of xn, put answer, so that whatever you got the previous time, that gets input into this function as the next value, as the next input. So you'll say 5 into answer. So in place of xn, you would write answer minus 1 whole raised to power 1 over 5. You'll write the formula exactly like this. Just replace xn with answer. Okay, let's do that. And that gives us this iteration. Now they will tell you how many decimal places to use for each iteration and for the final answer. In this case, they've told that you want 5 decimal places. You get this result? You have to make sure that you round off the values correctly to 5 decimal places. In this case, the first value turns out to be, x2 turns out to be 1.45406 to 5 decimal places. You press the equal to button again, that gives the next value. Now in this case, notice, you're getting 1.443636. When you round this off to 5 decimal places, the last decimal here will become 4. If you do not do that, if you write 3 here, you lose 1 mark. Okay, so in iteration, they deduct marks for very small things. You have to be a bit careful about this. Make sure you're rounding off values correctly. So you keep going on, keep writing down these values like this. Okay, until the number becomes stable and it does not change anymore. You have to write down each iteration. You cannot just do it on your calculator and write down the final answer only. No, you have to write down each iteration. So you keep going on, writing down every single iteration, and eventually what happens is it becomes stable and it does not change anymore. And you say, therefore, the solution that you have is x equals 1.441 to 3 decimal places. They wanted each iteration correct to 5 decimal places and the answer correct to 3 decimal places. So you write all the iteration to 5 decimals, and then when it becomes stable, you write down the final answer to 3 decimal places. These are the easiest 3-4 marks in your paper. Make sure that you do not mess this up. That's the result that you get from this. Okay. Now, sometimes, in very rare cases, they will not tell you the level of accuracy you need for iterations, but they will tell you what the final answer needs to be. For example, they might tell you for the final answer, you need 2 decimal places. Iterations will be 2 decimal places more than that. Okay. So if this is for the final answer, for iterations, you would be using 4 decimal places. If for the final answer, they say you want 4 decimal places, your iteration will have to be 6 decimal places. So sometimes it happens that they only give you the level of accuracy for the final answer, not for iterations. For iterations, you will just use 2 extra decimal places as compared to the final answer. Okay. But mostly they'll tell you what to do. Okay. Now, how do you get that iterative formula? Where does that come from? Now, there's a logic behind it. We'll skip that. But this is the method that we follow. We've got this equation, x power 5 minus 5x plus 1. If we had to make the iterative formula ourselves, how would that work? We've got 2 x terms here. One is x power 5, the other is this x here that's appearing with 5. What we do is we make any one of these the subject. That's not probably the correct terminology for this subject. You bring one x term to one side, everything else to the other side. So for example, you can choose this x term. Bring this to the left side. So you have x power 5, that equals 5x minus 1. Take everything else to the right side. So it becomes 5x minus 1 the other side. Now, the one that you have on the left side now, you want its power to be 1. It's power 5 right now. You want its power to be 1. How will that happen? You take power 1 over 5 on both sides, and that gives you this. X equals 5x minus 1 whole power 1 over 5. And then all you have to do is, on the left side with the x, you put n plus 1. On the right side with the x, you put n. And that's your iterative formula. This is one possible iterative formula that we could make from this equation. And that was the one that we used in the previous example. But you could have another iterative formula from the same equation as well. And that would be if you made this other x the subject, this x the subject, as in keep this x on one side, everything else on the other side. How would that work? You can take minus 5x to the other side, or take the other terms to the other side. So it becomes minus 5x equal to this. Multiply the whole equation by minus to get rid of that negative sign. Divide by 5 on the other side. You get this. And then all you have to do is put n plus 1 with the x on the left side, put n with the x on the right side. If you have multiple x on the right side, so that can happen as well. For example, you might have, another x here. With every x on the right side, on the right side, you put xn. Okay. Now these are two different iterative formulas. One of these will give you one possible answer. The other will give you another possible answer. So they will not both work at the same time, right? So for one solution, this might be working. For another solution, this might be working. So it's a power of 5 equation. So it can have up to 5 possible solutions. So some of those solutions might come from this iterative formula. Some of them might come from the other iterative formula. Okay. Now, how do you know which one? We don't have to know that. Okay. Yes, we do have to know how to make an iterative formula. Yes. But in the question, you will get a hint about which of these two formulas you would have to use, right? So it will be clear from the question which of these is going to be used. Okay. And we'll look at some examples for that. If you have the iterative formula given, for example, if you know this is the iterative formula, and you have to go back to the original equation. So this is the iterative formula. We want to know which equation does it come from. Okay. For that, we just do the opposite. Remember what we did here? We put n plus 1 and n at the end in the last step. We can get rid of n plus 1 and n from this. And that gives us this equation. Then just simplify that. And you get this power 5 equation. And that's the equation from which the iterative formula is coming. Okay, so you need to be able to do both ways. If you have the equation given, you should be able to find the iterative formula. If you have the iterative formula given, you should be able to find the equation that it comes from. Let's look at this example. You have this equation. It has one real root alpha. First of all, it says show that alpha lies between 1 and 2. You can do that, right? Convert it to f of x equals 0 form. Have only 0 on the other side. We already have that. Input those two values. One of them is negative, the other is positive. You say they have different signs. That's why the solution exists between those two values. Now they're saying there are two iterative formula derived from this equation, right? You can understand how they're derived, right? The same way we did it for the earlier example. You can make this x the subject or this x the subject, and that will give you these two iterative formulas. Now they're saying each formula is used with initial value 1.5. Show that one of these formulae produces a sequence which fails to converge. And use the other formula to calculate the value for alpha, correct to 2 decimal places, give the result of each iteration to 4 decimal places. Now, how would that work? Fails to converge. What does that mean? When we used this iterative formula earlier, the value was becoming stable somewhere. So we can say this value is converging to a specific value. This terminology is used a lot in iteration. They will say, this is the sequence of values that you're getting, and that's converging to a specific value, right? This is the sequence x1, x2, x3, x4, and it's converging to this final answer, okay? They're saying, show that one of these formulae produces a sequence, that means x1, x2, x3, x4, that fails to converge. Now, what does that mean? Let's apply these iterative formulas. This is one iterative formula. This is the other iterative formula. We start both of them with 1.5. Let's look at the first one. When we input 1.5 there, we just do this on our calculator like we did earlier. Keep writing down the iterations and see what happens. x2 is this, x3 is this, x4 is this, x5 is this. You see, the values are going towards negative infinity. They're not, the distances between consecutive values are actually increasing. Rather than becoming stable, it's going further and further away in one direction. So it's becoming, 0.37 here, negative, more negative, even more negative, and you keep going on for a few more steps, it'll reach negative infinity, right? It'll go towards negative infinity. Now, this is not converging. This is not becoming stable at any value. So that's what you say. This formula fails to converge. What about the other formula now? The other formula, you see, it becomes stable gradually, and it becomes stable at this value. And you say that's your final answer. You write down the final answer to do 2 decimal places. Now, in this case as well, It's very important. They wanted you to find the value for alpha. In the final answer, it's necessary that you write that alpha equals 1.67. Do not write x equals 1.67. Do not just write 1.67. Write alpha equals 1.67. They can sometimes deduct a mark for this as well if you don't write alpha equal to that. Okay. Again, in easy topics, they tend to deduct marks for very simple things. So in this case, you have to be careful. Alpha equals 1.67. That's your final answer. That's what you get here. Let's look at this example. And the first part, just want you to use this iterative formula to calculate the value for alpha. You can see that. In the second part, they're saying state an equation satisfied by alpha and hence find the exact value of alpha. Now, iteration does not give you an exact value. For example, if some solution was square root of 2, iteration cannot give you square root of 2. It can give you a decimal value, for example, 1.43. You can keep making this more and more accurate. You can get a value correct to maybe 10 decimal places, 100 decimal places, 1,000 decimal places. However, you can still not get exactly square root of 2 from that. So square root of 2 is exact value. This value is in decimals, that's not exact. Iteration will not give you answers in terms of square roots, for instance. It will give you only decimals or not even fractions, okay? So how do you find the exact value of alpha? First of all, they're saying state an equation satisfied by alpha. This is the iterative formula. How do you get back to an equation from this? Remove n plus 1 and n with x. You get this. Now simplify this. Simplify this equation. That becomes this, x power 4 minus 50x equal to 0. And that's an equation that we can actually solve directly as well. Take x common, that leaves you with x cubed minus 50. And the exact value of x, that turns out to be cube root of 50. That's the exact value of x. Or the exact value for alpha, that's cube root of 50. And you say, this is the exact value that we were looking for. This was an approximate value, as in the decimal value. This is the exact value, cube root of 50. Okay, and that's what you write there. The exact value of alpha is this, cube root of 50. Okay, that comes from the algebraic method, not iteration. Okay, now this is another thing. Another type of problem that you will see. You have this equation. It has one real. Okay. Find by calculation the pair of consecutive integers between which alpha lies. Now, what does that mean? Generally, what they do is they give you two specific numbers and ask you to prove that the solution lies between these two values. But in this case, they've not done that. They're just saying, find the pair of consecutive integers between which alpha lies. For example, if the solution was, let's say, 1.7, then you would say it lies between 1 and 2. Okay. So you have to find those two integers between which the solution lies. So what you do is you try some integers randomly. So generally in such questions, they start with smaller numbers, small positive values. If they don't work, try a few negative values as well. So in this case, we start from, for example, 0. What do you get at 0? 0 gives you minus 6. Try 1. When you input 1 in this, that gives you minus 6 again. You try f of 2, that gives you minus 2. You try f of 3, that gives you 12. And now you see the sign is changing. The sign is changing from 2 to 3. That means the solution lies between 2 and 3. Okay. So that's the value of alpha that we are getting. And that's what we're getting, that alpha lies between these two consecutive integers. Okay. So in this case, they did not tell you which numbers the solution lies between. Okay. You had to figure that out yourself. Consecutive integers. So you just try inputting consecutive integers. Start with 0, for instance. That gives you minus 6, minus 6, minus 2, 12. When the sign changes, that means that's where the solution is going to lie. Solution lies between these two cases. So that's x equals 2 and x equals 3. It lies between 2 and 3 in this case. Now, the second part. They use this kind of statement a lot in questions on iteration. Show that if a sequence of values given by this iterative formula converges, then it converges to alpha. Now, what does that mean? Sequence of values. What sequence of values? From the iterative formula, you get x1, x2, x3, x4, and so on, right? That's the sequence of values. If it converges, that means if it gets stable to a value, that means if it gives you a solution. If this iterative formula gives you a solution, then that solution would be alpha. That means the same solution that you got from this equation. So in these complicated words, what they're trying to say is show that this iterative formula corresponds to that equation. That the solution that you get from the iterative formula is actually the solution of that equation that we had. That's what you had to prove. Okay. Now, how do you do that? This is what we understand from this, right? So that the solution from this iterative formula is the solution of the equation in part 1. Now, we don't actually have to use the iterative formula at this point. You can see in the third part, they ask you to do that. We have to show that this iterative formula and this equation, they are basically coming from each other, right? How do you prove that? This is the equation. This is the iterative formula. You either rearrange this equation to convert it to a format like this, or the easier way generally is that you convert the iterative formula to a form such that it becomes this. So remove n plus 1 and n. That gives you this. Square both sides to get rid of the square root. You get this. Simplify that further, you get that equation, and that proves that this iterative formula is coming from this equation. If it's coming from that equation, that proves that the solution that you would get from this iterative formula, that will be the solution of that equation, because the iterative formula is actually coming from that equation. So that's what you prove in such questions, that the iterative formula and that equation, they correspond to each other. So generally, you would simplify the iterative formula and prove that that can be converted to that form. Okay. Last part is just the use of iterative formula. You can have a look at that. Okay, so that's the major concepts of iteration that we have. Then we have graphs in iteration as well. Let's talk about that next. Sketching different graphs. In your syllabus, you have done a number of different types of graphs. Iteration is where most of them are going to be tested. Okay. So let me quickly go through all the different types of graphs that you need to know about. And I'll try to quickly go through the method for sketching them. But of course, the assumption is that you know about it already. So we'll try to go through this quickly. Linear functions are straightforward. You just take 2 points and join them in a straight line. That gives you the straight line. For quadratic functions, there are 2 possible shapes, U shape and N shape. Okay, now just a point that you need to keep in mind. For all of these functions, the key thing that you need to remember is the shapes of these graphs, these graphs. Because once you know the shapes of these graphs, mostly what we would be doing would be, we would just be taking some values, plotting those values, and using those values, sketching a shape that we know it's going to look like. For example, for quadratic, we know it's going to be a U shape. We'll just take a few values and draw a U-shaped graph through that, or an N-shaped graph, depending on which case it is. Okay, so remembering the shapes is what is important. Apart from that, the important points that you need to remember, we will talk about them as we go along. So first of all, there are 2 possible shapes, U-shape or an N-shape for a quadratic function. When you get U-shape, when the coefficient of x squared is positive, you get a U-shape. When it's negative, you get an N-shape, right? C, the constant that represents the y-intercept. Now, for drawing these graphs, which are the important points? X-intercept, you do not always have to show them. If they're very straightforward to figure out, you can do that. Or you can just put them on your calculator. In fact, solve that equation on your calculator, you find the x-intercepts if you need to. And the y-intercept, but turning point is important. On a quadratic graph, you must show the turning point appropriately. How do you find that? Minus b over 2a or differentiation, any method, show the turning point on this graph. That's important. Cubic functions, there are 4 possible shapes for them. You could have a shape like this. The shapes on the left side, in which overall the graph is going in the upwards direction. From left to right, overall, the overall trajectory is that it's going upwards. That is what happens when the coefficient of x cube is positive. The graph is going to be one of these 2 shapes. And when the coefficient of x cube is negative, then you have one of these two shapes. Now you do not need to be able to distinguish between these two shapes. It could be any one of these two, and any one of these two. That does not matter. Just remember that it's going to be one of these shapes. And how do you actually sketch the graph? Using the table function on your calculator. You must know how to use the table function on your calculator. You'll just plot those points and sketch these graphs through those points. For example, I'll just show this to you quickly for just this example. Otherwise, you can watch the calculator video for table function on my channel. Somewhere you'll find that to understand how to use table function. I'll just do this quickly for this particular function. You go to menu, you have this table function. The function is x cube plus 2x minus 3. You input that function there, skip g of x. G of x would be used when you have two functions at the same time. You would input both f of x and g of x at the same time. That will give you a single table that has both the functions values. In this case, we'll skip that because there's only one value. We'll have some starting point, some end point that we'll have to use. In this case, let's suppose we are using minus 3 to 3. Step means the gap that you want between values. In this case, you get these values on your calculator, x and y values. You'll plot these values, and using those values, you'll just draw a graph that looks like one of these shapes, right? So when you plot some values, you'll realize which of these shapes it is going to be. You just draw that, and that's it. Then you have reciprocal functions. Reciprocal functions are those functions in which you have x in the denominator. It could be like this. It could be like this. You can have square in the denominator. All you need to remember about such functions is that their graphs are going to be broken. They will occur in multiple parts, right? Because when denominator becomes 0, the graph will be broken at that point, and it will come in two different parts. Okay, just remember that, so that when you plot values, you do not try to join these points like this. You do not try to join these two graphs like this. That's not what you're going to do. It will come in two different parts. Okay, that's all that you need to remember. Otherwise, you just use the table function, plot some values, and whatever shape you get from that, you just draw that. For 1 over x or any other function that has just x power 1 in the denominator, the shapes are going to look like this. Okay, but you just plot them, and just remember they're going to occur in multiple parts like this. Then you have trigonometric graphs from paper 1. You need to remember how to sketch them as well. The sine graph, it looks like this. Remember the shape. For sketching that, just use your calculator. It will be in radians. It shows in degrees here right now, but you'll be drawing this in radians in iteration, not in degrees. Always use radians. Use radians to plot some points. You would remember the shape of the graph. It's going to look like this. Through those points, just sketch this graph. It could be sine x or any transformation of sine x. For example, 5 into sine of x minus pi over 4 plus 7. It could be like this. You do not have to think about transformation. Just put this whole thing on your calculator as it is. Make a table, plot those values, and sketch a graph that looks like this. It could be some shape like this. Okay, you just draw that, and that's it. Exactly the same thing for cos. Just remember the shape. Remember the shape of the graph. Plot values using the table function. Join them. You'll get a shape that looks something like this. Okay. For tan, remember the graph is going to occur in multiple parts. It's going to be broken at the points where the function is undefined. So when you input this function on your calculator, wherever you have undefined, at those values, you would have an asymptote. You'll have a vertical asymptote. And the graph is going to go either towards positive infinity at that point or towards negative infinity. Okay. And then the rest of the points, you can see how to draw them. That's what your tan function is going to look like. If it's some transformation where tan is multiplying by something or adding with, or you have plus minus something, you just put that on a calculator. Don't think about transformation. Just use the table function, plot values, and join those points. You get the result. Then you have cosecant, cot, and secant functions. Again, remember the shapes of the graphs. This is what the cosecant graph looks like. A U shape, an N shape, and it alternates like this. You will input these values in your calculator. Wherever you get undefined on your calculator, so it will be at 0 in this case, it'll be at pi in this case, it'll be at 2 pi. You don't have to make this table in your paper. You just look at the table on your calculator, plot those values, and make a shape like this. Just remember, when you have undefined, that means you have a vertical asymptote at that point. So you have an asymptote at 0, another at pi, another at 2 pi. At those points, the graph is either going to go towards positive infinity or towards negative infinity. Shape of the graph will tell you if it's going upwards or downwards. That's the graph of cosecant. Secant looks similar to that. It's just shifted to the left by pi over 2 units. In your calculator, you don't have buttons for cosecant and secant, by the way. For cosecant, you'll put 1 over sine. For secant, you'll put 1 over cos. Right? Plot these values, draw a graph like this. When you have undefined in the function, you draw asymptotes like this. Whatever it is, if it's cosecant 2x, just put that in your calculator. For cosecant 2x, you put 1 over sine 2x in your calculator. You won't think about transformation. Just put this on your calculator, plot those points, and make a shape that looks like this. That's it. For cot x in your calculator, you're not going to put 1 over tan x. You're going to put cos x over sine x. 1 over tan x is not going to give you correct values. Again, there's a logic behind that, but we're not going to go into that. For cot x, remember, you will be inputting cos x over sine x in your calculator. You'll be putting cos x over sine x in your calculator. You'll get some values, plot them. When it's undefined, you have asymptotes, and the graph is going to look something like this. Remember the shapes. When you remember the shapes, you'll plot some points and you'll understand what the graph is going to look like. So this looks like tan, but it's flipped, right? Tan was like this. This is flipped. That's the graph of cot. Okay, just put that on your calculator, get the result. You can do it like this. Then you have exponential and log functions. E power something or log of something. How do you sketch these graphs? For exponential function, for example, you could have some number multiplying outside. You could have some power of e, some number adding or subtracting outside. Similarly, for log function, you could have something like this: some number multiplying outside, some number multiplying or added inside, some number added outside, right? Now, for these two graphs, exponential and log, roughly, these are what the shapes are going to look like. These are the 4 possible shapes that you would have for the log graphs and the exponential graphs. Right, roughly, this is what the shapes are going to look like. These 4 shapes. These are 4 different graphs. This is 1, 2, 3, 4. One of these shapes you would get when you draw the graph of either log or exponential. Now, the difference is exponential graphs have horizontal asymptotes. So they will be almost flat at some point. So they'll go like this. They'll go like this here. And this will also go like this here. And like this. So exponential graphs have horizontal asymptotes. Log graphs have vertical asymptotes. So they will be extended to this side like this. They'll be going vertical here, a vertical here. But roughly the shape is going to be one of these 4. Now, how do you draw these graphs? For exponential function, there are 2 things that you have to keep in mind. Where the asymptote is going to be, and one important point that you always have to plot. Now, what's that? The important point that you also have to plot, that you always have to plot, is when the power of the function is equal to 0. So you'll put the power equal to 0, minus 2x plus 4 equal to 0. The value of x that you get from that, that's the important point that you would always show on the exponential graph. Okay? That's this point here. At that point, you will see that the graph is going to quickly change its trajectory, that it would be less steep on one side, but then after that point, it becomes very steep all of a sudden. So that point where where the direction of the graph changes significantly, that is the important point. What's that? Whenever the power is equal to 0, you always have to mark this point on the graph. Put the power equal to 0, you get some value of x from that. The corresponding value of y in this case turns out to be minus 2. Plot that point. You have to show that point on this diagram. Okay, then what about the asymptote? Remember, exponential graphs have horizontal asymptote, and that asymptote is going to be the number that's adding or subtracting outside. Y equals minus 3, that's the asymptote. If there's no number outside, then the asymptote would be y equals 0. Okay, if you have some number adding or subtracting outside, then that's the asymptote, y equals -3. So in this case, this horizontal line, this is the asymptote of this graph. The graph is not going to cross this line. The graph is not going to cross this line. It's going to, go very close to this line here like this, but not go below this line. That's not possible. Okay. So now you've got the asymptote. You draw that dotted here. You've got that important point. How do you actually draw the graph now? Take one point to the left of the important point, take one point to the right, and that will show you how the graph is going to look like. So in this case, I took 1 point on the left side, 1 point on the right side, and that gives me this and this. For exponential and log functions, tables are not, the table function is not helpful. For this, you would just input values yourself. For the rest of the functions, you will always use table function, plot those values, and draw the shape based on that. This is how you would do the sketch of exponential graphs. For log graphs, the important point is going to be when the inner part is equal to 1. That's the important point that you always have to show. So 2x minus x equals 1. What's the value of x that you get from that? X equals 3.5. You have to show this value. Okay. Now, this is 1 point. You have to show this point on the diagram. What about the asymptote in this case? The asymptote in this case is when the inner part is equal to 0. That's when you get the asymptote. When the inner part is equal to 0. That's x equals 3. That's a vertical line. So the graph is not going to cross this vertical line x equals 3. That's the asymptote of this graph. Close to this line, the graph is either going to go towards negative infinity or towards positive infinity. Depending on the shape, you can figure that out. So you take this important point. That's 1 point that you have. This point. Now you take 1 point to the right of that, 1 point to the left of that, and you will understand what the shape of the graph looks like. Close to the asymptote, it's going to go towards negative infinity. On the other side, it goes like this. And that's it. That's your graph. Okay. So you need to remember for both of these graphs, what important point you have to show and what the asymptotes are going to be. Okay. Important point and the asymptotes for both of these graphs, you need to know them. Because in these graphs, sometimes they don't even tell you the interval. That's in which interval you have to draw these graphs. For the other graphs, they will always tell you the interval. For these two graphs, they sometimes don't even tell you the interval. In that case, you have to make sure that you show this important point and also the asymptote, and based on that, you would understand what part of the graph that you need to draw. Okay. So these are all the different graphs that you need to be able to sketch in this topic. Let's have a look at some problems that involve graphs now. So it says, by sketching a suitable pair of graphs, show that this equation has only one root in this interval. How do we show that? We have two functions here, one on the left side, that's y equals 2 cot x. Another function on the right side, y equals 1 plus e raised to power x. What we do is we draw those two graphs. The important point for the exponential graph is when the power is 0, right? X equals 0. We take that point and then we draw that graph in that interval that's given 0 to power 2. That looks like this. And we draw the graph of the other function as well, that's cot x. How do we draw cot x? For cot x, in our calculator, we put cos x over sin x. So we'll put 2 cos x over sin x in our calculator for cot. Okay. And then just plot values. You'll get a graph that looks like this. This is how I would, do it. Make sure calculator is in gradient mode. Put f of x as 2 cos of x divided by sin of x, for instance. That's your first function. Now, in this case, since you know the interval, 0 to pi over 2, you can just put g of x, the other function, as 1 plus e raised to pi x. That's the second function. And that gives you this next step, actually. Where do you start from 0? End at pi over 2. Now, the step should be such that you have sufficient number of values within this interval. So generally, if you have a trigonometric graph involved, I recommend that you at least divide the interval by 4. So pi over 2, divide that by 4, and that gives you pi over 8. So you have pi over 8, pi over 4, 3 pi over 8, pi over 2. These values are what you plot on the x-axis. And that they should be sufficient to make you understand what the shape is going to look like. If you still don't understand, if you still don't understand what the shape is going to be like, then you have to take more points. You'll have to break it down further. But generally, if you remember the shapes of the graphs, dividing by 4 is going to be sufficient. So pi over 2 divided by 4, what's that? That's pi over 8. Okay. And now you get these values. You plot those values. Now, the problem with table function is that it does not give you exact values. So you should know what the values on the x-axis are. So values on the x-axis, when you divide it by 4, they're going to be pi over 8. Then 2 pi over 8, that's pi over 4. 3 pi over 8, and then pi over 2. So these you should know, so that you know on the table, the first value, the second value, what are they giving you on the x-axis, and then you just plot the corresponding y values for them. At 0, you're getting an error for f of x. That means this function is undefined. So you have an asymptote for cot here, right? You plot the rest of the points, 4.8 to 0.8, and then finally 0. That's the last point that you have here. You plot those points and you sketch a shape like this through those points. Okay. And then the other one, the exponential function, you have those points as well. Plot those values and you draw a graph like this through them. And that gives you the graph. And then you say, the question is saying, show that this equation has only one root in this interval. How do we show that? We have to write down now that there's only one point of intersection. Since there is only one point of intersection, that is why there's only one root. Writing down this statement is important. Otherwise, even with all of this effort, it's a 2-mark question. If you don't write that statement, you only get 1 out of those 2 marks. So if there's only one root, you write that there's only one point of intersection. That is why there's only one root. And you can mark that point in the diagram as well, that this is the one root that we've got. Okay. For trigonometric functions, they will give you the interval. For exponential and log functions, sometimes they don't give you that. So you'll have to figure that out yourself. Okay, just give me a minute. I'll be back. Okay, let's look at this example. So they're saying, sketch this curve, and hence by sketching a second curve, show that this equation has exactly one real root. Now, we have to state the equation of the second curve as well. Now, how do we do that? They want us to sketch this curve first of all, y equals ln of x plus 1. Now, remember graphs of functions, O levels, this is one function that you have. What's the other function going to be? We want in this equation that ln of x plus 1 is on one side, everything else on the other side. So we can rearrange this so that we get ln of x plus 1 equal to 40 minus x cubed, right? And now this is one function that we would draw, y equals ln of x plus 1, and the other one would be y equals 40 minus x cubed. These are the two functions that we would draw. We can sketch them like this. For the log function, consider the important point, the asymptote, sketch that, and then according to that, take a similar interval for the cube function. You'll just do this on your calculator. You don't have to write this down here. I just showed this for wrote them down for notes, but you'll just draw this table in your calculator, plot those values for the cubic function. This is what the graph is going to look like, and then you say that there's only one point of intersection. That is why there's only one root. Hope you can have a look at this later on in your own time as well. And that's how this would work. Then they're saying, verify by calculation that the root lies between 3 and 4 by calculation. How do you do that? You bring all terms to one side, leave only 0 on the other side, and then put those values one by one. One is negative, the other is positive. Sign is changing. That means there's a root between those two values. Now the next part is saying, use this iterative formula to find the value of alpha. Okay, so you can do that as well. The last part, deduce the root of this equation. So based on that, now you have to deduce the root of this equation. Now, how do you do that? How is this connected to anything that you've done before? You found the solution of this equation. And based on that, they want you to find the solution of this equation. How are the two connected? You have to think about that. Let's write down those two equations here. One is this, and the other is this. Let's compare the two. This equation, using iteration, gave us the solution x equals 3.377. Now, when you compare that with this, we have 40 on the right side for both of them. And on the left side, what's happening is we have x cube here, and here we have e raised to power y minus 1 whole cube. So it looks like what's happening is x has been replaced with e raised to power y minus 1, right? And that's the same that we have here, same thing that we have here as well. It's in a different format, but it's actually equivalent because y equals ln of x plus 1. If you take this to the other side, it becomes e raised to power y equals x plus 1, and x equals e raised to power y minus 1. So that's the connection that you get between these two equations. X has been replaced with e power y minus 1. Now, what does that mean? The values of x that we got as solution from there, the value of x that we got, that is now going to be the same as e raised to power y minus 1. So we say e raised to power y minus 1, that equals this value, and find the value of y from that. Okay. So it's, again, show a couple of more steps. Here, what I've done here is that I've just used this directly. But if you wanted, you could also do this. E raised to power y minus 1 equals 3.377. And that gives you e raised to power y equals 3.377 plus 1. And then take log on both sides, and that will give you the same thing as that. Okay, so you can do it either way, and that gives the value for y. Okay, so sometimes this can happen as well, that they make you solve one equation, and using that, you have to solve another equation by finding the connection between them. Okay. Okay, a few more examples, and then we end. Let me just see if there's anything different anywhere. Let's just show the solutions and we. Okay, this is another equation, equation that we have. Secant x equals 3 minus x squared. We have to sketch graphs for this. Which graphs do we draw here? Secant x is 1 over cos x, so that's one graph that we draw. Again, just input values in your calculator from 0 to pi over 2, right? Break it down into 4 parts like this. Put values in the calculator, table function, right? Plot those points and make the shape that you know of. When you have undefined, that makes it an asymptote. Otherwise, you just, plot those points, plot those values, and draw a graph through them. They're saying show that it has only one root. So you're clearly right. There's only one point of intersection. That's why it's only one root. The next parts are pretty straightforward. We can have a look at this working. It's the same type of question. If a sequence of values given by this iterative formula, it converges, then it converges to the root of the equation in part 1. All you have to do is show that this iterative formula corresponds to which equation? Yeah, this equation in part 1. It corresponds to that, right? How do you do that? Simplify the iterative formula, remove n plus 1 and simplify everything and convert it to that form. Okay. Then you have iterative formula. Make sure calculator is in gradient mode. Sometimes the first parts of these questions, they tend to be a bit tricky. So that's circular measure. Sometimes it's differentiation. Sometimes it's integration. So that's other topics that a lot of people struggle with, especially circular measure, because those of you in A2, sometimes you end up forgetting the A1 concepts. You need to make sure that you revise them as well. You need to know circular measure that is often tested. In iteration like this. So you sometimes have to make extra lines to do some calculations. This is a relatively difficult one. You can have a look at this working. That's not iteration, that's the circular measure. You can see that the iteration parts generally they're going to be relatively easier. The first part will be some other topic when you're doing this question in the exam. If you get stuck on the first part, it's okay, leave that, but do not leave the whole question. As in leave that for the end, not just leave it all together, but leave that for the end of the exam. But do not skip the second and third parts. They will be the easiest on the paper. for iteration. Do them right away at that point so that you don't end up missing them at the end. But you can do the first part at the end if you cannot figure it out in a few minutes. Then just skip that and come back to that at the end. But do not skip the rest of the parts, okay? You can have a look at that working. Okay, that's how you would do it. Okay, there's just one small thing that I want to tell you about this. We have this diagram that shows the graph of this function. The curve intersects the x-axis at the points a0 and b0, where a is less than b. You can see that in the diagram, a and b. These are the x-intercepts of this graph. We need to find the value for b, first of all. How do we do that? It's polynomials, basically. They're saying b is an integer. So remember, we talked about this in polynomials. If you have an integer solution of a polynomial, it will always be amongst the factors of this constant. So try some factors of 6, plus minus 1, plus minus 2, plus minus 3, plus minus 6, and see which one of them satisfies the equation. That will be the solution. Now, the trick that we discussed for this was solve this equation in your calculator directly. The integer solution that you get from that, in this case, you'll get the solution x equals 3. Just show the working for that in your paper. Show that when you put x equal to 3, the equation is satisfied. So that means the value of b here, that should be 3. Okay. That's the value that satisfies this equation. We discussed this in polynomials. Then hence show that a satisfies this equation. Now this is important. A and b are the points of intersection of are the x-intercepts of this function. Both of them are x-intercepts of this. How do you find x-intercepts? By putting y equal to 0. So that's what we do here. In this equation, we put y equal to 0, and that's the equation that we got in the first part. This equation, its solutions are going to be b and a. Now, in the first part, we found one solution. We found one solution, and that one solution was 3. X equals 3 is one solution. If you know one solution of a polynomial, how do you find the others? Using polynomial division, right? If x equals 3 is a solution, we can say x minus 3 is a factor. Do long division, find the other factor, that's this. And then you say, this other factor, when this put equal to 0, that is going to give you the other solution. Okay? They are saying, show that a satisfies this equation. So you rearrange that now and convert it to a form like this. Convert that to a form like this. Okay? So this is what you want to convert it to. So you rearrange this, think about what variable you have to make the subject. So you see, you've got 3 divided here. That means most likely it will be this x that you would have to make the subject. Or maybe not. Let me look at this, a square, a cube, 2, yeah. So this will be the x that you would want to make the subject, this x, because you have 1 over 3 here, right? And the x square, a square and a cube, they are both on the other side. So square and cube, they will be on the other side. So what you do is you try to make this x the subject, as in keep this on one side, everything else on the other side. And that's what you end up getting. And you know, at that point, the solution that you're looking for, at that point, x is equal to a, put x equals a, and that gives you that equation that they were looking for. A has to satisfy this equation. Okay, because it has to be a solution of this equation. So when you rearrange that, this is what we end up getting from that. All right. Then they say use an iterative formula based on this equation to find the solution, find the value for A. How would we do that? First of all, what iterative formula do we use? We've got this as the subject. We talked about this when we discussed how to derive an iterative formula. We've got one variable on one side, everything else on the other side here. They've already made you convert it to this form. You just put n plus 1 here and put n with the a's on the right side. That's the iterative formula that we got. Okay. The next thing is, how do we know what value to start from? They have not given us any starting point here. Right? They have not given us any starting point here. We have not even proved that the solution lies between any two values. Remember, the starting value is supposed to be your best guess about the solution. Look at the graph. Look at the graph. If this value is 3, what do you think A is going to be roughly? If this is 3 units, Then what about A? It's close to maybe 1 unit, slightly less than that. So your starting value for iteration is going to be your best guess about the solution. If this is 3 units, we could say this is somewhere close to -1. So you could use -1 as a starting point. Okay, you could use minus 0.9, minus 0.5. Any of them would. It's somewhere between minus 0.5 and -1. So that's what you use as a starting point. You say A1 is equal to -1. Then you just put that in the iterative formula, solve that, you get the result. And that's the result. That's the answer that you get from that. Okay. This is just another example. First part is fairly straightforward. They have cot here. So when you have to use this on your calculator, cot will have to be replaced with 1/tan for that. Right? So 1/tan of half x minus 3x equal to 0. Then you input the values of x. One of them turns out to be positive, the other negative, and you get the result from that. The second part says, show that if the sequence of values given by this iterative formula converges, then it converges to alpha. Again, the same question. We have to show that this corresponds to that equation that we were given there. This was the equation. So we start from the iterative formula, try to rearrange this, and convert it to that form. The important point to remember here is tan inverse of x is not the same thing as cot x. These are two different things. Tan inverse is a different function. Tan of x whole power -1, that would be 1/tan x. And that can be written as cot x, but not tan inverse of x. Tan inverse of x is something totally different. That's a different function. That's the inverse function. Tan inverse is not the same as cot x. Tan of x power -1, if you had this, that can be written as cot x. So do not think that you want cot at the end. So just replace this tan inverse with cot. No, that's not correct. Cot will come when you have 1/tan somewhere. For example, here, if you have tan of this, you want to convert it to cot, you take reciprocal on both sides, and that gives you cot here and 3x here. And that proves that result that you wanted to find there. That's all that you need to know about iteration. I hope that was helpful. If you have any questions, you can let me know.